Alright, chapter number 2, descriptive statistics. So in descriptive statistics, we're going to look into numerical method lah. Numerical method. So under numerical method, remember it utilize quantitative variable or quantitative data. So under quantitative data, we know that there are two types of quantitative data, which is discrete quantitative and continuous quantitative. But we're also going to look into a group data and ungrouped data for a numerical methods. So we are looking into numerical methods lah, because this is a statistics course. So numerical method, there are two types of numerical method for group data and ungrouped data lah. So we're going to look into a measure of central tendency, which is mean, mode and median. Measure of dispersion, right? We want to know the spread of the data. So how much the data spread from the mean, right? So we're going to use, we're going to learn standard deviation and variance, right? And next, we're going to look into a measure of central position. Measure of central position. We're going to learn about quartal. First quartal, second and third quartal, right? So this is the topic that we're going to learn in this chapter, right? For organizing and graphing data, right, we're going to look into qualitative data and quantitative data. This is just a introduction. I just want to know, I want you to know what we're going to learn in this chapter. So for qualitative data, right? So qualitative data consists of categorical data, right? So we're going to learn how to do a frequency distribution, pie chart, bar chart. So under bar chart, there are several types of bar chart, which is a vertical or horizontal bar chart, cluster or multiple bar chart, and the last one is component or stack bar chart, right? So vertical bar chart or horizontal bar chart is just a simple bar chart, right? Consists of one variable. Cluster bar chart means that they have a category to measure. So they have two bar in single category. So this is category number 1. For category number 2, right? They have 2 or 3 bar or more, right? Bar in one category. For stack bar chart is they have a single bar but it's stacked with many category, right? It called as stack bar chart lah, ataupun in some book called as a component bar chart, right? For quantitative data, we're going to learn about stem and leaf plot, box plot, and frequency distribution and histogram. So remember, nampak kat sini, there are frequency distribution can be in either qualitative data or quantitative data. It can be, we can do frequency distribution for qualitative and quantitative data, right? So now let's look at measure of central tendency, the first subtopic for numerical method, right? Measure of central tendency is very simple. Basically, we are looking into mean, mode, and median, right? Mean, mode, and median. So mean is the average, mode is the most frequent occur, and median is the middle point, middle value, right? So in the real life situation, it is helpful to describe data by single number that most representative to the entire collection of number, right? So this is what we call as a measure of central tendency. They consist of mean, mode, and median, right? So mean, I just want to emphasize, in this chapter we are only focused on sample mean, sample measure of central tendency lah, which is statistic, right? So that's why we are using measuring mean and median and mode for sample lah, right? So this is a symbol for mean, which is x bar. This is a symbol for mean. Then the formula for mean is summation of x divided by n. X is the observation. Right? For example, let's say you have a number, right? For some observation, let's say 5 observation, let's say 5, 4, 5, 3, and 2, right? So this is x1, this is x2, this is x3, x4, this is represent the x5. So the formula of mean will be summation of xi from I equal to 1 until n and divided by n. So n is the number of observation. Right, so how many n we have? So we have 5 observation here, right? 1, 2, 3, 4, 5. So n will be 5 lah. So summation of xi means that 5 plus 4 plus 5 plus 3 plus 2. So you need to add every number in the set of data lah. This is very simple, and if you want to find mean, you need to divide by number of observation. So this is divided by 5. So you will get the value of mean, right? So the next measure of central tendency is median. Median is the middle value from the arranged data. Right? Arranged data in ascending order. Right? So kita highlight dekat sini is the middle value of the arranged data in ascending order. Means that before you calculate median, you need to arrange data in ascending order from the smallest value to the largest value. Right? For example, let's say we take this example 5, 4, 5, 3, 2. So we need to arrange data from the smallest number 2, 3, 4, 5, 5. We need to arrange the data, right, from the smallest to the largest. And then we need to find the location of median. So before we go further, the symbol for median is x tilde. X with the tilde, right? So this is the symbol for median. Okay, so we need to find the location of median. So location of median is n plus 1 divided by 2. So 5 plus 1 divided by 2, which is 6 over 2 equal to 3. So how to know the position? So this is position number 1, position number 2, position number 3, position number 4, and position number 5. So the location of median, this is not median yet. Ini bukan value of median. This is where is the median is located. Right? So 3 is the location of median. So then median will be equal to 4. Right? So as you know, I already explained it to you. The median is the middle value of the arranged data. So this is the middle value of the arranged data. Right? This is a simple example, and later on we will look into the complicated example. Right? So the step is first we need to arrange data in ascending order, and then find the location of median and locate the median value. This is very simple. So to find the location of median value, we need to use this formula. Right? So dia kata kat sini, if n is odd, the median is the middle of the data. And if n is even, the median is the average of two middle number. Let's say another example, yang apa yang dia cakap dekat sini, this is the odd number, right? So n equal to 5. This is odd number. So let's say we look into n equal to 6. Let's say I letak 4, 4, 5, 6, 9, this is 5 and 11. So let's say this is the number that we have. So n equal to 6. This is the even number. So this is position number 1, position number 2, 3, 4, 5, and 6. Okay. So now, location of median, right? Location of median. N plus 1 divided by 2, which is 6 plus 1 divided by 2 equal to 7 over 2 equal to 3 over 0.5. So 3.5 dekat sini tak ada kan? Dia ada 1, 2, 3, 4, 5, 6. So 3.5 somewhere between 3 and 4. Boleh nampak? Somewhere between 3 and 4. Right? Actually between 3 and 4 lah. In the middle value of the 3 and 4 kan? So to get 3.5, 3 plus 4 divided by 2, which is equal to 3.5. So this is the same method we use to find the median. So the median 5 plus 6 divided by 2, which is equal to 5.5. Right? So this is a simple or brief explanation on the definition of median. Right? I hope you understand the median value. So how to interpret the median? Right? Tadi kita tengok mean, we don't really touch how to interpret the mean. The mean, let's say this is the mean. Mana mean tadi? This is the we compute mean. Kita compute dulu. Right? Let's say 5 plus 4 plus 5 plus 3 plus 2. Oops, tak kena. 5 plus 4 plus 5 plus 3 plus 2. 19 divided by 5. So, should be 3.8. So, 3.8. So, 3.8 is the value of how to interpret mean. The average, let's say this is a score, exam score. Let's say, for example, the average exam score for, let's say, 5 students is 3.8. So that's how we interpret the median lah. So for median, so since we know that the definition of median is the middle value of the arranged data. So since median here is equal to 3.5, right? So maksudnya dekat sini, kejap ya, saya letak kat tepi sikit. So to make you understand how to interpret the median. So let's say this is 2, 3, 4, 5 and 5. So this is the median, right? 4 kan? So let's assume the total number, the total value dekat sini is equal to 100%, right? This is 100%, right? So the middle value here dekat sini represent 50%, right? So the median value is 50%, right? Kita boleh kata dekat sini, there are 50% of total observation is less than 4, while another 50% of total observation is more than 4. Sebab dia middle value, itu saja kita boleh interpret, right? 50% of the total observation is less than 4, and more than another 50% of the total observation is more than 4, right? So that's how we interpret the value of median lah. Right, let's look at into the last measure of central tendency, which is mode. The symbol for mode is X hat. X with a hat. Or any symbol, Y with a hat. Z with a hat. So anything with the hat is representing mode. Right? So mode is the most frequent value that occur in the data set. Right, let's look into this example number, this one, right, i.e. so 4, 4, 5, 6, 9, 1, 11, right? So we have n equal to 6. Betul? 6, right? So mode is the most frequent value. So the most frequent value dekat sini kita ada 4 lah. 4 appear 2 times. Right? Boleh faham, eh? Okay. Any question regarding the mean, mode and median? I think this is very simple, right? Right. We are just focusing on ungrouped data. Very simple. Right. So this is for, the calculation is for ungrouped data. Remember, this is for ungrouped data. So now let's look at into measure of dispersion. Measure of dispersion. You boleh dengar I punya suara? Still okay?
Boleh.
Alright,
Boleh, sir.
we just continue on measure of dispersion. Right, measure of dispersion, we will look into standard deviation and variance. So now, assume that let's say we have two situation here, right? Let's say I go to playground. Let's say playground A, playground A, and this is playground B, right? So in playground A, I have an A equal to let's say 10 children, and playground B, I have 10 children as well, right? So I measure the age of the children, right? And I got X bar equal to, let's say, 5. And this one also X bar equal to 5. This is X bar B, and X bar A. Can we say that both playground have a same distribution? Because we have measured 10 children, and we got mean for playground A is 5 years old, and mean for playground B also 5 years old. Let's say I distribute the data, right? I dapat macam ni. Let's say di playground A I dapat macam ni. Right. So this is the mean X bar A equal to 5. Let's say for a B, let's say I dapat macam ni. This is the mean XB equal to 5. Can we say both distribution of both playground have the same distribution? Boleh kata ke? Can you respond? Muhammad Akmal, can we say playground A and playground B have the same distribution?
Yes.
How many say yes? Khairunisa?
Yes. Good.
Idham Muhaimin? Yes. Basically, kalau kita tengok dekat sini, based on central tendency, based on the value of central tendency, we had a value of mean equal to 5 for both playground. But if you look into the shape of data distribution, the data for the distribution for playground A is quite dispersed or spread around the mean. For playground B, dia lebih konsisten ataupun lebih rapat dengan mean. Kita tengok dekat sini, and let's say this is the mean kan. So the observation might be somewhere here lah. Right? Maybe the smallest the smallest value of age is, let's say, 2 years old, and the largest will be 15, for example. Ataupun too far, let's say 10 years old lah, 10 years old. Let's say from for this one, let's say kita letak 2, let's say this is 7. So the distribution is around the mean, or maybe this one 3 to 7. Right? So that's why by relying on measure of central tendency itself is not enough, right? To know the shape of data distribution, right? To know the distribution of 2 or 3 or more than the distribution. So that's why we need to accompany the measure of central tendency with the measure of dispersion to know which whether the distribution is good for doing a prediction, or we need to collect more data, right? Obviously kalau kita tengok dekat sini, data dia lebih disperse. Kita tak tahu yang mana banyak kan. Yang kita tahu dekat sini lah, mode dekat 5. Maksudnya ramai children umur 5 tahun lah. Tapi dia punya dispersion, spread of kumpulan tu bukan dalam kumpulan yang sama lah. Dia lebih spread lah. Okay. So that's why we need to use measure of dispersion using standard deviation or variance. So characteristic of measure of dispersion, kita tengok characteristic, the more spread out or disperse the data, the larger will be the variance or standard deviation. Dia kata kat sini, kalau data tu lebih spread, right, so the standard deviation will be larger lah. So let's say dekat sini, let's say kita guna S, let's say S standard deviation will be dekat sini will be let's say 3.2. Let's say this one SB will be 1.5 for example. Sebab dia punya the spread of the data is dispersed, lagi besar compared to background B. And the definition of standard deviation or variance is the mean of the difference between observation and mean. Maksudnya the distance, let's say pada sini bagi you nampak jelas what is the definition of standard deviation. Oops. Let's say kita ada observation dekat sini. Let's say I buat macam ni. One, two, three, four, five, six, 7, 8, 9, let's say 10. Right? So boleh nampak? So the distance dekat sini, distance I am warna hijau. Distance daripada observation, this is observation number 1, and the mean. The distance dekat sini, semua distance. So the collection of distance, the mean of the distance between observation and mean is called as standard variance or standard deviation. Right? Sama juga dekat sini lah. Kita measure the distance and take the mean of all distance. This is what we call as variance or standard deviation. Right? Boleh faham? So basically, we still use the concept of mean or average, right? But in different form to measure the spread. Benda yang sama, right? That's why I said to you earlier, mean, mode, median is the fundamental of statistics. So later on, kita akan tengok semua akan measure menggunakan mean, mode or median, right? So the more clustered data, maksudnya data tu lebih kecil, so the smaller the variance or standard deviation. So this is the concept lah. So if all data value are all the same, that is there are no variation in the data. So they might be suspicious lah kalau data tu tak ada variation. Ataupun kalau kita pergi kat sekolah darjah 1, right? Semua umur 7 tahun. We are measuring the age. And of course, everybody in that standard is same age kan? Maksudnya tak ada langsung perbezaan. So, the mean will be 7 and standard deviation will be 0. Maksudnya tak ada variation langsung. Boleh faham So now let's look at the formula for variance and standard deviation for ungrouped data. So standard deviation, so let's look at into variance first. Variance, the symbol for variance is S square. This is a statistics, right? Means a sample variance. Sample variance, symbol for sample variance S square. And look into the symbol for standard deviation, just S. Means that if you want to get S, you just need to square root of S square. Right? Boleh faham tak? If you want to get S, you just need to take the surd of S square. So it will get S lah, sama juga. So the formula for variance is 1 divided by n minus 1 multiply with summation of x square minus summation of x, then you square divided by n. And remember that summation of x square is not equal to summation of x and then you square. It's totally different value. Right? So this is how we calculate variance, and if you want to find standard deviation, we just need take a square root of variance. Right? So the definition of a standard deviation is measure a dispersion of set of the data from its means. Macam tadi saya cakap, we take the distance, the mean of the distance between observation and mean lah. Right? So kita measure mean of the distance. So the more spread the data, the higher standard deviation or variance. The more clustered the data, the smaller variance or standard deviation. Right? Are you okay? Boleh? Let's look at this topic, and then we take a 5-minute break. Right? Skewness. Measure of skewness. Before we go to measure of position, let's look at into a measure of skewness. Skewness means that we want to know whether the data is normally distributed or not normally distributed. Why this is important? Because in statistics, there are two methods, commonly known two methods, which is a parametric test and non-parametric test, if you want to do a inferential statistics. So if you want to use a parametric test, most of the parametric tests require the data should be from a normal distribution. For non-parametric tests, it's assumed a distribution free, like it doesn't care whether it's normal or not normal distribution. Right? And then we want to know the distribution, the type of distribution, which is normal or not normal, because we want to know the characteristic of the data. Right? So let's say we are measuring the age of population in Malaysia, right? So of course we can see the distribution should be skewed to the right. Maksudnya orang muda lagi banyak daripada orang tua, right? Boleh faham? So that's why we need to carefully choose which measure of central tendency when we know the skewness of the data, right? When the data is normally distributed, remember, I belum masuk lagi. When the data is normally distributed, right? So normally we are using mean and standard deviation as measure of central tendency. When the data is not normally distributed, normally we are using median, mode, interquartile range, or quartal deviation lah. Right? So now let's look at the definition of skewness. Right? Skewness measure the lack of symmetry in the data. So a distribution is symmetric if it look the same to the left and the right of the center point. Right? Means that dia bentuk dalam, dia macam bentuk bell shape. So kenapa dia kata bell shape? Dia tiru macam bell yang lama dulu lah. Bentuk bell yang lama kan, masa zaman cowboy tu kan. Kalau you pergi ke Penang Free School, you akan nampak bell. Right? You pernah tengok bell? Right?
No.
Okay, good. So bell shape means that dia bentuk seakan-akan bell lah. So I lukis tak cantik sangat, tapi seakan-akan bell. So the characteristic of symmetric distribution or normal distribution, dia kata symmetric or normal distribution. So dekat sini dia kata dia ada 100% of the data, right? 50% of the data sebelah kanan, another 50% of the data on the left hand side. Maksudnya area on the left hand side dekat sini sama juga dengan area right hand side. Maksud sini 50% and then this one also 50%, right? So remember, on the first 1 hour ni I just explain the theory, right? Belum masuk practical lagi. And then dekat sini dia the characteristic of normal distribution is asymptotic distribution. Asymptotic distribution means that this is from negative infinity to infinity. So it will never touch the axis. It will never touch the axis, right? Because the probability of an event cannot be 0, right? So this is the shape of normal or symmetrical distribution lah, right? Let's look at for skewed distribution. So skewed distribution, we have two commonly known skewness, which is positive or negative distribution, right? Positive distribution also known as a skewed to the right distribution, and negative distribution also known as skewed to the left distribution. Kalau kita tengok the tail of the distribution is more longer to the right. So this is what we call as skewed to the right distribution. If the tail is longer to the left, this is what we call as skewed to the left or negatively skewed distribution. Kenapa negatively skewed? This is the data starting from negative infinity to infinity. So it is skewed to the infinity to the negative side. This is negative infinity to infinity skewed to the positive side. So that's the reason we call positive skewed or negative skewed, right? So this is example of the skewness by looking into the histogram. So kita nampak dekat sini dia skewed to the right distribution, and then this is a skewed to the left distribution, right? Boleh nampak. Okay, we normally we cannot have the normal curve kat sini lah. Kalau kita buat histogram, kita buat stem and leaf, box plot, there are no normal distribution curve kat sini, tapi kita boleh imagine the distribution, the curve, right? Whether it's skewed to the right or distribution or left, skewed to the left, right? So another method, instead of identifying the skewness from the graph, right? Another method is by utilizing the measure of central tendency and measure of dispersion, right? So there are two formula can be used by using Carl-Pearson coefficient of skewness, right? So the formula number one is the same formula, so we'll give a same result. Formula number one, mean minus mode divided by standard deviation. So mean, this one mean minus mode divided by standard deviation. Another one is 3 multiplied with mean minus median divided by standard deviation. So in either formula is also can be used to identify the skewness of the distribution, right? If the skewness value, we don't care the value, whether it's how large the value. What we care is the magnitude of the value. If the value is negative magnitude on the negative side, means the negative value, so we can say that it is the distribution is negatively skewed or skewed to the left. If the value of the skewness is positive, then we can say that the distribution is positive, skewed, or skewed to the right distribution. If the skewness value is equal to 0, then we can say that the distribution is normally distributed or symmetrical distribution. Boleh faham? So dekat sini dia ada 3 side. So this is a positive, 0, negative. This is a positive, skewed. This is a symmetrical. And this is negative, skewed. So the value of skewness, right? Okay. So this is a second method, right? This is a second method. So there are several methods can be used to identify the skewness. The first method that we have discussed here is the shape of distribution. We look into the graph, whether the graph is skewed to the right or skewed to the left, depending on the tail. Whether the tail is more longer on the right, so it's skewed to the right. If the tail is longer to the left, it's skewed to the left. It's same, then symmetrical distribution. So the second method is we can use a skewness, Pearson coefficient of skewness. There are two formula can be used. And the third method is based on measure central tendency itself. Based on measure central tendency itself, kita boleh tengok dekat sini. So we know that this graph, right, number 1, number 2, and number 3. This is a negatively skewed graph, right? So normally we know that the highest value will represent the mode. This is going to be mode, right? And then the next value going to be present median, and then this one going to represent mean. This is from negative infinity to infinity. So if the value of mode is larger than median, larger than mean, then it's skewed to the left distribution. If the value of mode is smaller, this is negative infinity to infinity. The value of mode dekat sini, this is mode, median, and mean. If the value of mode is smaller than median, than mean, then it's skewed to the right distribution or positively skewed. If the value of mode equal to median, equal to mean, these three values are equal, then it's a symmetrical distribution or normal distribution. Boleh? Can you understand?
Yes.
Yes.
Right.
Yes.
So I think we take a 10-minute breaks. We're going to continue on 10 o'clock before we go to measure opposition. Okay, let's continue on measure opposition. So just now we already looked into a measure of central tendency, measure of dispersion, and measure of skewness, right? So these measures are very important when you want to know or describe the data and to identify whether you want to use a parametric test or non-parametric test. So we already looked into a measure of central tendency named as mean and standard deviation. So standard deviation is we want to know the spread of the data, right? So what if the data is not normally distributed or not symmetrical, where there is a skew to the right or skew to the left distribution? So we cannot use mean and standard deviation, right? So we need to use others measure of central tendency, which is median, right? And accompanied by interquartile range or quartal deviation. So to measure quartal, right, So it lies under a topic of measure of position. So standard deviation is a measure of dispersion that associate with the mean. So quartile measure dispersion associate with median, right? So it associate with median means that all the characteristic of median is based on quartile, right? So now let me explain the nature or characteristic of the quartile. So let's say we have 100% of data, right? So this is data, right? Let's say from some data lah, let's say 5, 6, 7, 8, 9, 10, 11, right? So we have 7 n equal to 7. So the total data is 100%. So Quartal divide the data into 4 parts, right? It divide the data into 4 parts, which is, let's say, this is the first part. Let's say first part. This is first part. Second part. Besar sangat. Let's say letak satu lagi lah. This is the third part. And then tambah lagi satu line bagi dia nampak penuh. Right? This is 12. So now this is part number 1. This is first part, second part, third part, and fourth part. Right? It divide the data into 4 equal parts. So the first part consists of 25% of the data. The second part also consists of 25% of the data. And third part also consists of 25%. So with the fourth part. So the total should be equal to 100% lah. Right? Boleh faham ah? We divide the data into 4 parts. Right? Boleh?
Boleh.
Quartile number 1 represent the data of the first part. This is quartile number 1. Quartile number 2 consists another 25%. This is the total of 25 plus 25 will be 50 lah kan. So this is what we call as quartile number 2. For quartile number 3 consists of another 25% of the data, right? Right, consists of another 25% of the data, so which is 75%. So this is quartile number 3. Boleh faham? So this is the point of quartile number 1. This is the point of quartile number 2. This is the point of quartile number 3. The concept of quartile start with the arranging the data from the smallest to the largest, same as median, right? Median kita tengok tadi median dia adalah middle value of the data, consists of 50% of the data, right? Remember, listen carefully, this is very important. If you want to understand quartile, you need to understand median first. Median consists 50% of the total observation. 50% of total observation dekat sini lah. This is a 50%, right? Median, which is also equal to quartile number 2. So that's why we say that quartile number 2 is equal to median. How to interpret quartile number 2 or median? 50% of total observation having value less than median value, while another 50% of the total observation having value more than median value. Right, so this is how we interpret quarter number 2 or median. Right, understand? Huh? So now let's look at into quarter number 1. Quarter number 1 only consists of 25% of the observation. So the interpretation is same as median. We can say that 25% of the total observation is having value less than quartile number 1. While another 75% means that 25 plus 25 plus 25, 75 is having value more than quartile number 1. Boleh faham? Konsep tu jangan confuse sebab kita kena faham konsep number 1 dulu. Median. Median dia kata apa? 50% of the data is having value less than median or quartile number 1, number 2. While another 50% of the data is having value more than quartile number 2. For quartile number 1, it's the same concept. But for quartile number 1, it only consists of 25% of the data having value less than quartile number 1. While another 75% is having value more than quartile number 1. For quartile number 3, it consists of 75% of the data. We can say that 75% of the data is having value less than quartile number 3, while another 25% of the data is having value more than quartile number 3. Boleh faham? Very simple explanation. So since the data is divided into 4 parts, right? Remember tadi I tunjuk dekat you, it divided into 4 parts, right? So the location, to find the location of quartile, right, is also same as finding the location of median. So what is the step of finding median? First, we need to arrange data in ascending orders, right? So from the smallest to the largest. Second is we need to locate the value, the median value, kan? Locate the median value, the value of quartile lah, quartile I. So for quartile I, remember tadi kalau median, location of median is n plus 1 divided by 2. Right? So I'm going to show you how we get the formula. It based on quartile I. Quartile I where I is equal to quartile 1, quartile 2 or quartile 3. The general formula will be I multiplied with n plus 1 divided by 4. Kenapa 4? Because we divide the data into 4 parts. 4 equal part. Part 1, part 2, part 3, part 4. Boleh faham? So that's why if you want to find the location of quartile 1, it will be 1 multiplied with n plus 1 divided by 4. Quartile number 2 will be 2 multiplied with n plus 1 divided by 4. So this one should be n plus 1 divided by 2. Same as median lah. Right? For quartile number 3 will be 3 multiplied with n plus 1 divided by 4. Very simple formula. We just need to remember the general formula. Right? Boleh? Any question before we proceed further? Right. So you boleh baca dekat sini lah. So first quartile, I dah bagi dekat sini lah. First, arrange data in ascending order, find the location of quartile 1 and locate the value of quartile 1. Sama je step dia. Right? For quartile number 2 sama dengan median. Quartile number 3 sama juga, arrange data in ascending order, find the location of quarter number 3 and locate the value of quarter number 3. That is how we find the value of quartile. Right. So this is an interpretation, sama je macam tadi saya cakap. For first quartile, 25% of the total data is less than quarter number 1, and while in 75% of the total observation or total data is more than quarter number 1. Right, sama je. You can read by yourself. This is how we calculate, nanti kita akan tengok this one. Kita akan skip dulu, ataupun you boleh tengok nantilah. Okay, tak apa, kita boleh tengok sekarang. So, dia ada dekat sini beberapa data. 3, 5, 7, 6, 4, and 5. So, this is how we calculate mean, standard deviation, and variance lah. So, for variance, if you are using the old calculator, this is the step lah. So if you are using the newest calculator, I advise you to use a new calculator kan, 570ES, because you can recheck balik apa yang you tulis. Kalau you the old calculator, you cannot recheck. So you key in the data, you cannot recheck balik apa yang you key in. Whether you key in the right number or wrong number, you cannot recheck. What you can do is you double confirm by redo the step balik. Right? So, but if you are using the new calculator, 570ES, you can recheck balik number yang you key in ni. Right? So, you remember you ada 2 jam saja untuk final assessment, 1 hour untuk test. So, you need to calculate fast, right? And correct, accurate. So, by using older calculator, you can refer to the notes. Right? By using a new calculator, you need to click on mode, right, mode, and click on 3 for stat, and find 1 for 1 minus variance. So tekan 1. So dia akan keluar macam ni lah. So you can key in the data, 3 equal 5 equal 7 equal 6 equal 4 equal 5 equal. So as I said, you can recheck balik number yang you key in lah. You can make sure the numbers that you input into the calculator is correct. Right? By using the older calculator, you cannot do that. Boleh faham? So once you already key in the data, then you click AC and click on Shift 1 for stat, and click on 3 for sum. Then you will get summation of x square. So remember, mean is equal to summation of x divided by n. Right? So from here you can easily tekan 2 sama dengan, it's equal to 30. So this is equal to 30 divided by how many n? 1, 2, 3, 4, 5, 6. So divided by 6. Right? So 30 divided by 6 should be equal to 5. So mean is equal to 5. Otherwise, another one, let's say you want to find variance. 1 divided by n minus 1, right? Multiply with summation of x square minus summation of x, and then you square divide by n, right? This is how we find the variance kan. So we can input the value into the formula, 5 minus 1 multiply with, tadi kita tekan shift 1 sum number 3 and summation of x square 1. So dapat 160 minus summation of x is equal to 30 power of 2 divided by 5. So you input the value into the calculator, you will get the answer. Right? Or you can use the calculator to find the exact value of mean without calculating. So tekan shift 1, you akan nampak the value of variance, VAR. Number 4, tekan 4, and then you tekan 2 untuk mean, X bar. 2, it should be equal to 5. So you double confirm that this is the answer for mean. For variance, tekan sama juga, shift 1, shift 1, tekan 4. So dia akan ada kat sini sigma x and sx. Right? Sx, sorry, this is standard deviation. S saja standard deviation. So we are calculating variance kan? S square. So S square Sx is the value of standard deviation. Sebab dia tak ada square. Right? Remember the symbol for variance is S square. Symbol for standard deviation is just S. So tekan 4. So this is the value of standard deviation. So if you want to know the value of standard deviation is 1.4.414. Right, for variance, we just need to square this value. So it's equal to 2. Boleh faham? Boleh? Very simple, right? This is how we use a new calculator, ES. If you are using the older calculator, there are many steps to get lah. Right, a bit complicated and easy to make mistake. So that's why I strongly advise to you to buy a new calculator. Right, boleh eh? So let's look at the example. So the following data represent the age of tourists at Hotel Samara, Langkawi, 2015. So we have 1, 2, 3, 4, 5, 6, 7, 21 data. Right? 21 data. So we need to calculate mean, mode and median. So they already give you answer lah. Sebab you nak tengok first kan sebelum you buat the real question. So we have, if you want to find mean, summation of x divided by n, you need to plus everything divided by n. 21 is equal to 24.52. So this is the value of mean. So how to interpret the average age of tourists is 24.52 years old. Right? Mode is the most frequent value occurs. So kita tengok dekat sini, the most frequent value we have berapa banyak yang muncul. This is 28. 28 muncul 2 kali. So yang lain-lain semua muncul sekali saja. So the mode will be 28 lah. So how to interpret the mode? Most of the tourists are 28 years old. This is how we interpret lah. Right. And for median, first we need to arrange data in ascending order, right? So I already arranged data in ascending order from the smallest to the largest value. Remember, I nampak dekat atas ni ada position of the data. So I already position the data lah. From the smallest, this is position number 1, position number 2, number 3, and 24, 21. This is the observation, right? So we need to find the location. 21 plus 1 divided by 2 is equal to 11. So this is the median value. Median is equal to 26. So how to interpret? 50% of the tourists are less than 26 years old. While another 50% of the tourists are more than 26 years old. Simple explanation. Right? Tak payah buat complicated. Boleh? So to find variance and standard deviation, same as just now, I already show you using calculator. So you just input the data into calculator, right? All the data ni masuk dalam calculator, right? You need to find the value of summation of x square, summation of x, and then you input the calculator, then find the value for variance and standard deviation as well, right? And to find the shape of data distribution, remember there are 3 methods. I already showed to you 3 methods. First method is by using apa? The shape of distribution by graphical view. The second method is by using a Pearson coefficient of skewness formula. There are 2 formula. The third method is by using measure of central tendency, right? If you look at into the data, the result that we already calculate, mean is equal to, so mean is equal to 24.52, mode is equal to 28, and median is equal to 26. So if you tabulate, right, So we can see that the mode is larger, right? Larger than mean. So mode, so this is mode is equal to 28. Median is 26. This is median. And the smallest value is mean, which is equal to 24.5. So we can say that the distribution is skewed to the left distribution or negatively skewed. Boleh? So this is by measure of central tendency. If you are using Pearson coefficient of skewness, you can use either one formula. So mean minus mode divided by standard deviation, mean 24.52 minus 28 divided by 10, which is, this is the standard deviation, right? So equal to negative 0.33. So that since we have a negative value, so we can say that is a negative skewed distribution, right? Negatively skewed distribution. Boleh, eh? So now let's look at into the last question, right? The last question, we want to find the first and third quartile. It's the same procedure as median. We need to arrange data in ascending order, and then we locate the value of quartile, which is 21 plus 1 divided by 4, which is 5.5. 5.5 is somewhere between here, right? 14 and 19. So 14 plus 19 divided by 2, it should be equal to 16.5. So another method is, we know that 50% of the distance between 14 and 19 is the middle, is the quarter number 1, right? Maksudnya dekat sini 5.5. Maksudnya 5 dekat sini sudah ada 5. Maksudnya dekat sini 5. Okay, I tunjuk dekat you cara paling senang lah you nak faham the concept of this formula, right? 5 and 6, right? So we want to find the value of 5.5, and of course 5 is already here, right? So 5 plus, we want to find 0.5 between 5 and 6. So 0.5, which is the next value, 0.5, multiply with 5 plus 6. Oh, sorry, 6 minus 5. 6 minus 5 equal to, so this one should be equal to 1, and then this one multiply with 0.5, it should be equal to 5.5. So benda yang sama. This is the concept lah. How to find the value of quartile when you have a decimal point. So we apply this concept to the real number. So 14 plus 0.5, 19 minus 14 should be equal to 16.5. So this is a value of quartile 1. So the quartile 1 means that 25% of the observation of the tourist is having age less than 16.5 years old. 25% of the tourists is having age less than 16.5 years old, while another 75% of the tourists is having age more than 16.5 years old. That's how we interpret quartile 1, right? Same goes to quartile number 3 jugalah. Right, kita tengok quartile number 3, benda yang sama lah. First, we need to locate the quartile number 3, location of quartile number 3. So we will get 16.5, use the same formula, 31.5. So we can say that 25% of the total observation or total tourists is having age more than 31.5, while another 75% is having age less than 31.5. Okay, boleh? Ada soalan tak? Okay, now let's look at into this data. Question example number 2. So example number 2, and then kita masuk coefficient of variation. And we will start at coefficient of variation lah. So example number 2, A company that sell mail order computer system needs to know the typical week sales in order to plan for inventory or staffing. The company select 10 weeks at random from the last year and obtain the data in thousand. Right, in thousand lah. So this is represent 218,000. Right, and so on lah. So basically we have 1, 2, 3, 4, 5. We have n equal to 10. So we need to find mean, mode, and median. Let's find mode first because this is very simple. So let's look at the value of that occur most frequent. 222, 222, 222. And then the next one, 223, 223. And others are uniquely occur, right? So the mode will be 222. So the most ni apa sales kan is 222,000 lah. This is number 1. Number 2, we try to find mean. So mean is summation of x divided by n. So in final exam or in test, I require you to put all the formula value in the formula. So now kita masukkan value. First, we need to click on mode and click on stat and 1. So we will get this one, 218, sorry, 218, oh, masukkan, and then 230, susah pakai ni, 231, masuk, 235, 222, 220, 223, 222, 225, 227, 223, and 222. So you can recheck balik lah. First is 218, 31, 35, 22, 23, 22, 25, 27, 23, 22. Alright. So once you already input the data, tekan shift 1, tekan 3 untuk sum, tekan 2. Right. So 2224, 2248, sorry. Right. Divide by 10. So even though you can use calculator to find mean instantly, so 224.8, right? I still require you to put the individual value. So each value will consist of 0.5 marks. This is 1 marks. So altogether 2 marks. Right? So what happen kalau you tak letak this value, you letak this one saja. So I assume that you tak buat pengiraan lah. No methods, no answer. No method, only answer 0 marks. No method, only answer 0 marks. Methods, answer wrong, method right, 1 marks. Alright, so number 3, let's use another color. So number 3, so to find median, first we need to arrange data in descending order. For the smallest value is 218, and then the next largest is 222, 222, 222. And next is 223, 225, 227, and 231, 235. Is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Lagi satu apa? Yang mana I lepas? Oh, this one. Sekali lagi. So you need to carefully arrange the data lah. 223, 225, 227, 231, 235. So let's position the number. This is position number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So second step is we need to find a location of median. So n plus 1 divided by 2, which is 11 divided by 2 is equal to 5.5. Right? So 5.5 is somewhere between 5 and 6. So the median will be 223 plus 223 divided by 2, which is equal to 223. Boleh? So how to interpret this one? Most of the sales are the average of sale is 224, and dekat sini 50% of the sales are less than 223,000, and when another 50% of the sales is more than 223. Okay, so let's look at calculate the variance and standard deviation. So let's look into variance first. Variance is 1 divided by n minus 1, summation of x square minus summation of x, and then you square divided by n. Right? So 1 divided by 10 minus 1. This is our total observation. So summation of x square, so you tekan input data tadi kan, tekan shift 1, sum number 3, and summation of x square number 1. So it should be 505,574. So 505,574 minus, so summation of x is 220, 2,248 power of 2 divided by 10. So you input the value into calculator, or if you don't want to input, you just tekan shift 1, tekan 4, tekan number 4 for s square s, you will get the value of standard deviation. But this is not a value of variance, kan? So you need to square this one. Should be equal to 24.84. Is it? Yes. So for standard deviation should be, this is the square root of answer, 4.98. So how many decimal point you want to write? Write in up to 2 decimal point. Cukup lah, 2 decimal point cukup. So now, C, determine the shape of data distribution and interpret. So let's use as coefficient of skewness. Right? So mean minus mode divided by standard deviation. Or you can use either one. Another one is 3 multiply mean minus median divided by standard deviation. Let me use the first one. Mean is equal to 224.8 minus, the mode is 222, and the standard deviation is 4.98. And of course, this one we will get a positive value lah. You just tekan saja dalam calculator, right? Tekan dalam calculator, 224.8 minus 222 divided by 4.98. So this one should be equal to 0.56. So we can see that there is a skew to the right distribution. Right? Skew to the right distribution. Based on the skewness, coefficient of skewness. Right? Boleh ya? So next, we need to calculate the first and third quartile and hence interpret the meaning of its value. So let me copy this one. Sebab kita dah ada arrange data. Oops, mana dia? Oh, dia turun bawah. Okay. So, first we need to arrange data in ascending order, right? Next is we need to find location of quarter 1, which is n plus 1 divided by 4, which is 11 divided by 4 equal to 2.25, I think. 11 divided by 4. 2.75. 2.75. So 2.75 is somewhere between 2 and 3, right? So quarter number 1 will be 222, which is nombor 2 ni dah termasuk 222, plus the balance is 0.75, right? 0.75 multiply with 222 minus 222. So this one should be equal to 0, sorry, 0. So multiply with 0, quarter number 1 is equal to 222. Right? And then quarter number location of quarter number 3, which is equal to 3 multiply with 11 divided by 4. So 33 divided by 4. 33 divided by 4 should be equal to 8.25. Right? It's somewhere between 8 and 9. So quarter number 3 will be 227 plus, this is number 8, right? And the balance is 0.25. 0.25 multiply with 231 minus 227. So we just plug in the value into the calculator. So this one should be 227 plus 0.25 multiply with 231 minus 227 tutup kurungan is equal to 228. And you should notice that the value should be between 222, between dia punya range ni lah. This is 2022, 2022. And then between the range of 227 and 231. Dia tak boleh lebih, tak boleh kurang. Right? So this is the value of quarter 1 and quarter 2. So how to interpret this one? The sales, so we can say that 25% of the sales are less than 222,000, and while another 75% is more than 222,000 for quarter number 1. For quarter number 3, 75% of the sales is less than 228,000, while another 25% of the total sales is more than 228,000. Right? Okay? Boleh? Ada soalan? Is there any question before we proceed for the last subtopic for this chapter?
No, sir.
Right.
No,
Good.
sir.
So now we move to the coefficient of variation. So last topic, we already discussed about mean and standard deviation, and how important of standard deviation to describe the shape of distribution, to describe the distribution of two distribution lah. Right. So another method is by looking into coefficient of variation. If you want to compare two distribution or more than two, right, we use coefficient of variation to measure the spread or disperse the distribution. So the coefficient of variation, COV or CV, right? So kita pakai dekat sini kita pakai CV lah, COV lah. Benda yang sama, CV or COV benda yang sama lah. Right. Tapi I lebih prefer kita pakai CV lah. COV will represent covariance, right? CV. CV is used to compare the dispersion or spread or variability of two or more data distribution, right? So coefficient of variation compare standard deviation and mean of data distribution and convert its value to percentage. So instead of looking to the shape of distribution by graphical view, right? Tadi kita tahu masa example yang I tunjuk important of standard deviation. Right, let's say kita ada dua distribution. Right, playground A, right, dia macam ni, right? Playground B dia lebih rapat sikit, right? So this is to identify the spreadness of the distribution by looking into graphical view, right? So let's say we have a lot of data, right? So we want to know which one is more spread and which one is more consistent, right? So we no need to draw graph to identify, right? To draw a graph, let's say satu atau dua variable, then okay lah. But if you have more than 1,000, right, to draw graph and look what is every single variable to compare the distribution might be too unpractical. So that's why coefficient of variation comes to help you to identify which one is more spread, which one is more consistent by looking it on the value. So the formula is standard deviation divided by mean multiplied with 100%. So it will represent as it will express in term of percentage lah. So the smaller percentage will represent the more consistent distribution. The larger percentage will represent the more spread distribution. Right. So kalau compare antara dua ni, CV A and CV B, CV A should be larger lah, let's say 50%, CV B should be 15% for example. Right, dia mesti kecil sebab dia kecil, dia more consistent. Lagi besar dia punya CV, lagi spread dia punya distribution. Right. So dia kata kat sini, if CV distribution A is greater than CV distribution B, then we can say that distribution A is more dispersed or spread than distribution B. Kita nampak dekat sini. Let's say this is A, this is B. Right? So B is more consistent, less variability compared to B, compared to A. Right? And of course, CVA is more than CVB. Right? So dia kata dekat sini, we also can say that distribution B is more consistent or less dispersed, more stable than distribution A. A larger relative variation implies less consistency, while smaller relative variation imply more consistency. Consistent means that the observation is around the mean, closer to the mean. Less consistent means that the observation is disparate, more dispersed around the mean, right? So that is how we measure coefficient of variation. Let's look at into example number 3. So now example number 3, 3 classes taught by lecturer were given the same test after 3 weeks of lectures. So the score were as follows. So dia kata class A, dia ada mean, median, mode and variance. Class B as well, class C. So using appropriate calculation, determine which class has most consistent performance. Maksudnya, kelas mana yang semua performance lebih kurang sama. Dan kelas mana yang ada murid yang pandai, ada murid yang kurang pandai. Ataupun ada murid yang skor banyak, ada murid yang skor sikit. Right, that is the correct word lah. Right, so to know which class has most consistent performance, we need to use coefficient of variation. Let's say coefficient of variation for class A, mean divided by standard deviation multiplied with 100%. So mean is 85 divided by Standard deviation is square root of 144 multiplied with 100%. CVB sama juga 65 divided by square root of 64 multiplied with 100%. So remember, this is the variance kan? Kita nak standard deviation. So this is what? So CVC, this is B, right? 65 divided by square root of 100 multiplied with 100%. So we need to remember the formula, right? Oh sorry, standard deviation divided by mean. Salah. Terbalik. Standard deviation divided by mean. Terbalik. S divided by mean. Multiply with 100%. So this one, square root of 144 divided by 85. Multiply with 100%. And this is square root of 64 divided by 65 multiplied with 100%. And this is square root of 100 divided by 65 multiplied with 100%. So can you calculate this one? Square root of 144 divided by 85 multiplied with 100. So it should be equal to 14.12%. And for the second one is, this is 65 and this is 64. So it should be equal to 12.31%. And the last one should be 100. So this one should be 15.38%. So we can say that CV C is more than CV A more than CV B. So class B is more consistent performance compared to class A and C. Or we can say that class C is more dispersed compared to class B and A. Class A is more dispersed compared to class B. Or we can say class B is more consistent to class A. Class B also consistent to class C. Class A is more consistent to class C. Right? So this is the general, this is the final interpretation lah. Right? Class B is more consistent performance compared to class A and B. Class A and C. Right? Okay. So the next question is, which distribution score is skewed to the right? Sketch the distribution by showing the position of mean, median and mode. So skewed to the right, remember skewed to the right, macam ni bentuk dia. So it's starting from negative infinity to infinity. So it's supposed to be mode is smaller than median, smaller than mean. So mean is the larger. So look at into this result. So which one has the largest mean compared to others? So this is mean, mode and median are the same, right? So this is what we call as skewed, normally distributed or symmetrical distribution. So if you look at it, this one, mean is the smallest compared to mode and median. And for class A, mean is the largest compared to median and mode. So since they want you to find skewed to the right, so we can say that class A having positive, skewed. So we can draw macam ni lah. So negative infinity. So this is the mode and this is negative infinity. So mode is equal to 65, right? Mode is equal to 65. Median is equal to 75 and mean equal to 85. So skew to the right distribution. Okay? Ada soalan tak?
So, boleh lukis macam tu je ke?
Ya, macam tu je. Dia suruh sketch kan? Sketch macam ni lah. Kalau dia suruh draw, means that you need to take out your graph paper and draw properly lah. Okay? Any question before we end our session? This is the first part of chapter number 2. Second part, we will look into a box and whisker plot, stem and leaf. Lagi kita tengok histogram, frequency distribution, bar chart and pie chart. Right? So I think that's all. Ada soalan tak before we end our session?
Tidak, tiada.
So